Bismillahirrahmanirrahim. Assalamualaikum students. Alright, so this slide here, basically this video here, we're going to cover on source transformation. Okay, so what is this source transformation? If you can look at the name has the word transform there. So basically this source transformation is a process to replace, to transform. If you have a voltage source that is in series with a resistor, you can transform it to become a current source in parallel with a resistor. Alright. Now, to give you a clear understanding, okay, based on the definition, I'm just going to show you this. So it says that if you have a voltage source that is in series with a resistor, we shall call that resistor R, that one we call it Vs, we can transform it to become a current source that is in parallel with the resistor. Yep, the same resistor. Let's call that IS. And if you notice just now in the definition, it has the vice versa. What it is saying is, if you have current source instead that is in parallel with a resistor, you can transform it to become a voltage source that is in series with the resistor. Alright, so you might want to ask, Madam, what if it's a dependent source? Simple. If you have a dependent current source that is in parallel with a resistor, you can transform it to become a dependent voltage source that is in series with the resistor. Okay, and of course it's also vice versa. Okay, so let us put numbers into it. So if I have a voltage source that is in series with a resistor, I know that I can transform it to become a current source in parallel with the same resistor. So for argument's sake, I'm just going to put that 10 volt and let's just put that 2 ohm. So I want to transform it. So you know that it's going to be a current source in parallel with the same resistor value. Now, but how do I determine the direction of the current and its value? So the symbol there, okay, the plus sign, just have to remember the plus sign, it means the arrowhead is there. But what about the value? Ohm's law, V equals to IR, I equals to V over R. So therefore, this I over here equals to 10 volt divided by 2. You will get your 5 ampere. So the value of the current here is 5 ampere. Let's do another example. Now this time you want to transform from a current source that is in parallel with a resistor, you want to transform it to become a voltage source that is in series with a resistor. Put the value there, 10 ampere, make that 5 ohm. You know that there will be 5 ohm, okay, because it's the same resistor. Now, how about now? What is this voltage source? What about the plus and minus sign? Do you want to guess? That's right. You might guess it right. Okay, look at the arrowhead. That will point out the positive symbol. Okay, and the minus sign goes over there. What about the value then? So the Vs by Ohm's law, V equals to IR. So taking all the value from here, so I is 10, your R is 5, gives you a 50 volt. Voltage value here is 50 volt. Easy, isn't it? So what do you think? So far so good? Alright, so all you have to remember is, if you have a voltage source in series with a resistor, or you have a current source that is in parallel with the resistor, you know you can do some sort of transformation. Alright, so if you can see there, okay, it is a more elaborate example. Okay, but before we go into this example, I just want to share you some tips. Alright, so this is what I usually tell my students. I told them, if let's say they want to know whether or not they're on the right track of doing source transformation, they should not use any method beyond chapter 2, which means if you are using mesh analysis or nodal analysis, it means you're not doing quite right. So how do you want to solve a source transformation? I want you to imagine at the back of your head, this is what you want to achieve at the end of your analysis. I want you to imagine having a voltage divider circuit or a current divider circuit. Remember I mentioned nothing beyond chapter 2? What else in chapter 2? You have resistors in series and parallel. You have voltage source in series. What happened? So voltage source in series, you can add up. What else in chapter 2? If you have a current source and they're connected in parallel, yep, you can add it up. So everything you need to do to solve source transformation is within chapter 1 and chapter 2. Okay? Okay, so now let us look at this example here. Alright, now if you remember the previous slide, I mentioned to you that at the back of your head, I want you to imagine that you will reduce the circuit. You will do some reduction. Okay, you transform the circuit until this whole circuit will become a circuit where you can do voltage divider or you can do a current divider analysis. Alright, that's number 1. Okay, number 2. Okay, I want to tell you that start off with the obvious. For example here, the resistor here, they are in series. Resistors in series can add up. So you solve the obvious first. Okay, so if you can see, if let's say for example, if there is a current voltage source, if there is a voltage source over there that is in series with 5 volt, you know that voltage source in series, so you can add up. Alright, so that's number 2. So first off, I want you to imagine that you're going to have either a voltage divider circuit or a current divider circuit. Number 2, I want you to do the obvious, and this is number 3 is optional. Okay, usually if the question asks for a current passing through a resistor, like this example here, I usually say do not touch that resistor. Okay, do not touch that 7 ohm. Do not manipulate the resistor. Okay, leave it alone. That way you will find it much more easier for you to do your transformation analysis. Okay, so here is the final slide. We already finished the theory behind source transformation. So inshallah during class time, you will see how we will complete the elaborate example. Alright, bye. Assalamualaikum.